So in order to find that average rate of change, we have to find the y values. Do we know the y values of our function? What do you think? Do you know them? No. No, we don't. How are we going to find them? Math them, right? We're going to calculate. We have to do some calculations. We have to do some calculations in order to figure out what those y values are so that we can use the formula. Okay, we're going to get out our big math brains for a minute. Okay, this is the interval. Here is your x1 term. This is your x2 term. So we're going to calculate the y1 term and the y2 term. Okay, and we're going to do this using our big brains. Okay, so the y2 term, that means we have to evaluate. Are we going to do y2 or y1? I guess I'm doing y2 because that's what I wrote. We have to evaluate this at -1. Since x2 is -1, to find the corresponding y value with x2, so we got to find y2, we got to use the x value that we're calling x2, right? They have to coordinate. So we're looking at the negative of -1 cubed plus 3 times -1. So that simplifies down to -2 is our y2 value. And we're going to do the same thing to find your y1 value. Okay, we're going to plug in the x1 term. So we're going to evaluate our function at -2. Okay, so we're taking the negative of -2 cubed plus 3 times -2. So now we have your two y values. We were given your two x values. So now we can go into your slope equation to find the average rate of change, the AROC, average rate of change. So that is y2 minus y1. So our y2 value is -2 minus our y1 value is +2. Okay, y2 minus y1 divided by x2, which was -1, minus x1, which is -2. Okay, and those two are given to you up there as your interval. The average rate of change, y2 minus y1 over x2 minus x1. So what is -2 minus 2? -4. And then minus a minus is a plus, so it's -1 plus 2. +1. So our average rate of change on the interval from -2 to -1 is -4. Okay, so now we're looking at this h function and we want to know what is the average rate of change from +1 to +4. So there's your x1 and your x2. So once again we have to calculate y1 and y2. I guess we can do y1 first. It doesn't really matter which one you do. But if x1 is 1, we're going to calculate h of 1. Right? So if we're using y1, that means we are plugging in the x1 value. So that's 1 plus 1 over 1 plus 6 is 2 over 7. Okay, for y2, we are plugging in +4 because that's our x2 value. +4, so 4 plus 1 over 4 plus 6. 4 plus 1 is 5, 4 plus 6 is 10. 5/10 can reduce to 1/2. Now let's find our average rate of change, also known as the slope. So 1/2 minus 2/7, y2 minus y1, divided by 4 minus 1, x2 minus x1. So we can simplify our average rate of change down to 3/14 divided by 3. Okay, so anytime we see a fractional division, right, so we have a fraction divided by a non-fraction, we're going to stop and do multiplication by the reciprocal instead. Okay, so we're going to make the bottom a 3 over 1. We're going to multiply by the reciprocal. Division is the same as multiplication by the reciprocal. Okay, so what's going to happen is this is going to become a 3/14 times 1/3. Right? The reciprocal of 3 is 1/3. So whenever we have a fractional division, either a fraction in the numerator, a fraction in the denominator, or both, we, rather than dividing by a fraction, we multiply by its reciprocal. Because how can we simplify 3/14 times 1/3? The 3 and the 3 divide out, right? Those ones divide to give you 1. So our final answer is 1 over 14. So the average rate of change of our h function from 1 to 4 is 1/14. The y value changes 1 and the x value changes 14. Okay, so the next problem we're given a graph. So we have the graph of g is shown. Find the average rate of change over the interval from -1 to 3. So once again, there's your x1 is -1. Here's your x2, +3. Okay? So let's figure out what is the y coordinate that goes along with the +3 x value. The y value is 4. So y sub 2 is going to be 4 because that's the y value when x is 3. And what is the y value when x is -1? 0. So y1 will equal 0. If you're given an equation, you have to calculate them. If you're given a graph, you can find the y values by using your eyeballs and your amazing counting ability. So our average rate of change, AROC, y2 of 4 minus y1 of 0, divided by x2 of 3 minus x2 of -1. Y minus y over x minus x. So 4 minus 0 is 4. 3 minus a negative is plus, is also 4. 4 divided by 4 is 1. Okay. So visually, we are finding the slope of the line that connects these 2 points. Okay, that is what we are finding on our graph, is what is the slope of the line that connects those 2 values. And as you see, it's probably a +1. We go 1 up and 1 over. That's the slope of this line. Okay, average rate of change means slope. So how about a table? It says find the average rate of change in life expectancy from 1850 to 2000. So 2000 is your x2. 1850 is your x1. Which means your y sub 2 is 81.83, and your y sub 1 is 46.1. So when we find the average rate of change, that's y2 minus y sub 1 divided by 2000, your x sub 2, minus 1850, your x sub 1. Okay, now I'm going to put this into my calculator and see what I get. 0.238. That's the average rate of change over that 150-year period of less than a quarter of a year longer life expectancy for women over that 150-year period. Okay? Wonderful job. Average rate of change. Okay, so we have some words down here. The rate of change of a function at a particular point is the rate the y values would change if the x values change, right? So we have to have 2 different things that are changing. Okay, so we can estimate, right? In pre-calculus, all we can do is estimate. We can estimate the rate of change by finding the average rate of change over a small interval, right? Or approximate. In pre-calculus, we can't actually find the instantaneous rate of change because we need calculus for that and a derivative. Okay, and then we can compare the rates at two different points from the concept by using a concept called a tangent line. Okay, a tangent line. So if we had a graph, let's call this a graph. This is a nice parabola. Okay, there's a parabola. Okay, and we can pick any point on that parabola, and we can figure out what the tangent line is. So the tangent line is one that touches in only one point. Tangent touches in exactly one place. Okay, so the tangent line is not a very well drawn one, but that would be like a tangent line, one that touches it in exactly one place. Maybe this one will be better. So here's an one here. All right, there's some examples of tangent lines. And what we did before, right, when we had 2 points, a left side and a right side point, if we have 2 points, this is called a secant line, just for comparison. So this is a secant line, one that crosses twice. A tangent line only crosses in 1 point. A secant line crosses from 2 points. Okay, so we can find average rate of change using a secant line, but you can find instantaneous rate of change using a tangent line. Okay, and you do that in calculus, and we did that finding the average rate of change a second ago. Okay, so here's some nice things. Put a star next to it. If the graph of S has a positive rate of change, then the graph of F is increasing. Likewise, if the graph has a negative rate of change, then the graph of F is decreasing. Right, so positive rate of changes was things like, being concave up that we talked about a couple days ago. Negative rate of change, F is decreasing. Then we have, right, concave down as your concavity. Okay, so we can estimate the instantaneous rate of change by taking very small intervals. A little bit to the left and then a little bit to the right. So we're given some examples here of whether these are positive rates of change or negative rates of change. Okay, a child's height or a child's age versus the child's height. Is that a positive or a negative rate of change? As the child grows, right, as the age of the child increases, what happens to the height of the child usually? It also increases. So this would be a positive rate of change, right? The child grows as it ages, he or she, right? That would be the normal growth pattern for a kid. Positive, until you get to be, of course, your growth spurt stops as you're a young adult. But kids have positive age versus height growth. Okay, how about a golfer's skill level versus a golfer's score? So as a golfer gets better, does the score go up or does the score go down? And actually the score goes down. So if you know nothing about golf, right, this is a very biased question. But as the skill of the golfer increases, the score of the golfer should decrease. Okay, as you get better at driving the ball, as you get better at selecting a club to hit into the green, right? As you get better at putting and reading putts, your scores should get lower as you get better if you're a golfer. Okay, and how about the height of a coin, the height from the ground of a coin dropped off the Burj Khalifa versus the speed of the coin as it falls? So height versus speed. As the speed increases, what happens to the height? It goes down, right? So this starts off very slowly. So this would be this is a negative, right? The golfer one is a -1, and this one is also negative. As the speed increases, the height decreases, of course, due to gravity. So estimating rates of change at a point. So here I want you to take your paper and fold it over your other paper so that you have a straight edge. Okay, the graph of F is shown along with the tangent line. So this line that we have on our graph is called the tangent line because it only touches your graph in exactly one place. Right? It doesn't cross it over. It doesn't go perpendicular. It is trying to touch it in exactly one place. Okay? So you can't find the slope, but we can estimate it. So what would you say about the rate of change at -4? In other words, what is the slope of this line? Okay? So maybe we're going to say this is a point. We're going to figure out what is the rise and the run. So how many in the y direction do we go? And then how many do we go in this direction? So let's count. What do we count? 1, 2, 3, 4 up, and 1, 2, 3 over. So if slope is rise over run, our slope is going to be 4 over 3. Okay, so that would be the rate of change of the tangent line. It's literally the slope of the line that's tangent at that point. Okay, so we can draw these other tangent lines, and I'm going to do the best that I can. Maybe this one looks like that. So, right, you can estimate that slope, and we can estimate that slope. Oh, that one didn't even touch, so sorry. Let's see, there it goes, and then this one is going to touch there. Okay, so the question says compare the slope at x equals 4 to the x equals 5. Which one is increasing at a greater rate, at x equals 4 or at x equals 5? What do you think? At probably x equals 5. Why would you say that the rate is increasing faster at x equals 5? Right, the slope of the tangent line is more steep or steeper. Right, the steeper the tangent line, the faster it is increasing. Okay, so that's how we can estimate it in pre-calculus, is by trying to calculate the slope of the line at that exact tangent point. Okay, but once again, in pre-calculus, we can only estimate it because we don't have the calculus skills to find it exactly.